Come on. Guys, ready? Wait, have a seat. Get your stuff out. Seated, perhaps. Gideon, have a seat. Pardon? Gideon. You're taking too long. You can do that sitting down. James, what happened? I'll be here on time.
I know.
Gotta be here on time. Last day of.
Two more.
I think so.
Today and Friday, and then we have quiz next thing. Wait, is there no gonna be no quiz this evening?
There's a quiz.
Why today?
Quiz on the 9th, on Friday.
Oh. This Friday?
Yeah,
No time to review in thoughts.
there should be time.
What's the point of having a quiz if you have to pass the next time?
Today we're doing day 5 and then a quiz, so day 5 and then flex day or the extra day we switched. Yeah. But yeah, that would be weird. Exactly the same thing. I agree with you. Here we go.
How many points do I want on each graph?
3 points.
You see that base on logarithm okay? Log base 3.
On the one and one of the things. But then really, think about it, it's not like the log and then log in this, which is kind of like they were They could have someone think about the like.
Yeah.
Okay. Did you finish? Yeah, I'm finished. Maybe there's some confusion stopping you. So let's go over this. Do we agree that the 3 to the x is a little bit easier than log base 3 of x, perhaps? Maybe first one is more intuitive. The numbers I'm going to plug in are -1, 0, and 1. So I think that I hope you all have this point on your graph. 0, 1, also 1, comma 3. Are we okay with that? 3 to the -1 is 1/3. Are we good with that? Just by definition of negative exponents. Okay, and that should be enough for us to draw a nice exponential curve. Bam. Now the next one is not as intuitive until you understand what it means. It's symmetric to number 1 because these two functions are the inverses
Yeah.
of one another, which means you just take the x's and y's and flip them. And it's that easy. So if you know the 3 points on the first graph, you should know the 3 points on the other graph, like 0, 1, 1, 0. 1, 3. Now let's just make sure, based on your knowledge of logarithms, do you understand what log base 3 of 3 means? It means 3 to the which power equals 3. So that's why the answer is 1. 3 to the first power equals 1. So when you plug in the 3, the output is 1. Log base 3 of 1 is 0. That's why the point 1, 0 is on the graph. 1 is the input, 0 is the output. Are we good with that being a 0 output? Good question. Right, we can put an x here. So 3 to the what equals 1. Yeah, that's 0 power equals 1. And then the other point is not quite as intuitive, but since we're relating it to the exponential, we know that it is 1/3, comma, -1. And that just comes from that -1, comma, 1/3 flipped. That's all it is.
So is it like, so we can graph like on a test or quiz, we can kind of just figure it out by getting the inverse of like the exponential.
Nice. Yeah. If you have to graph something like log base 6 of x and you freak out, like, how am I supposed to graph that? Maybe first you should graph y equals 6 to the x. Get those 3 points and then just flip the coordinates. If that would help, I think that's a good anchor to us and gets a little bit more intuitive. But yeah, so here we have this, and we can't forget about our vertical asymptote that logarithms have. And from here, from that graph, you can see that the domain is x is greater than 0. So what would happen if we try to put in a negative number? Something like log base 3 of -9. Yeah, but there's nothing. Like if you try to set this equal to x, and 3 to the what equals -9. There's no way to get a negative number out of an exponential. Just like we see in our exponential function, everything's positive. So yeah, if they try to put a negative number in the log, throw it out. Can't do that problem. Any questions? Okay. Let's finish up the packet from last time, the section. I would start with graphing. I would start with C first, but I'm gonna give you a moment to discuss or work on your own and just make this happen. Hold on. Okay, folks. Are you ready? I'm gonna explain first of all how to do A without looking at the graph. Whatever we put in here in this inside that logarithm, does it make sense that that has to be positive?
Yeah.
So you can go directly and say that x plus 2 has to be greater than 0 if you want to just go right to it. Algebraically, that's how to get that. So we see that x is greater than -2, so we could write that as -2 to infinity. Does that match the graph that you made? Cool. Take the equation of the asymptote. We'll do that after the function. Now to graph this. That's true, because we know that domain. It never hits that left side. Nice. So you'd be comfortable just saying x equals -2 right there. Great. Yeah, so I think we have a kind of a picture of what's going on and understanding of this function, if you could do it this way. But I really like to start with the function. I think it's a friendly place to start once you're good with that function. And we're not going to start with this crazy function. We're going to start with its parent, with the parent function, specifically y equals log base 2 of x. And if this freaks you out, if this still confounds you, then you go back to y equals 2 to the x. And that could just be in your mind if you wanted to. So in my mind, okay, I have 0, 1, that changes to 1, 0. I have 1, 2, that changes to 2, 1. And I have -1, comma 1/2, so 1/2, comma -1. This is my parent function. Yeah, and this 2 here means we're going to take all those points, move them 2 to the left, and this 3 means they go up 3. That's it. Things that could complicate it would be if we included stretches or negatives or reflections or stretches and things like that. So just things to be careful of. But this one is just as translation. So each one, and you really just could do this visually if you want. 2 to the left, 1, 2, 1, 2, 3. Oh, I think I've been doing green for the other one. But pathwise, I just went 1, 2, and then I went 1, 2, 3 to go there. That's it for that one. I'm not doing any sort of math. So to the left, 2, up 1, 2, 3. And then this one, it looks like I kind of lost that one. Back 2 and up 1, 2, 3. And let's not forget to include the asymptote. There we go. Find at least 3 points. That's what I'd be looking for. Any questions? Yes, this here?
You don't draw that.
Probably. That's an essential part. I need the 3 points and the asymptote. I should take that back. Not probably. Yes. So thank you for helping me be clear about that. Oh, any other questions? That's the question I was looking for. Let's start the new lesson. Okay, properties of logarithms. Okay, so you already know from exponential or exponents, if you have something like x squared times x to the fifth, that's equal to x to the seventh. We know this to be true. This is, I hope, not a surprise to anyone. There's a similar relationship. Well, let me put this here. So this is b to the m plus n in the notes. If you have a log of a product, since they're related to exponents, we could call this log base b of m. I'm having a hard time with my stylus here. Plus log base b of n. And the way to say this is that the logarithm of a product is the what of the logarithms? The sum. We call this the product rule. Note, log of a plus b doesn't fit this. It's only log, and I should say m plus m, since we're using that, excuse me. M plus m, it doesn't fit. You can't try to break that up. Don't try to distribute log over addition. Distributive property is only for multiplication. Okay, so with this in mind, a student who doesn't know better may just say this is log base 4 of 35, which is true, but that's not using the product rule to expand the expression. You understand what to do though? Check to see if you can use that. Okay, so here we have log base 4 of 7 plus log base 4 of 5. We are done. This is called expanding a logarithm. An essential tool for calculus. Try B and C. I'll call on a couple people to help me with those. You want to call me? Gideon, what did you get for B? So did you write the base 10?
Yeah.
Okay, good. So how did you know it's base 10? Is it base 10? Is it base 10? Is it?
Well, not really.
The what person?
It's like the common law.
Yeah, by definition, it's common law, exactly. So, thank you for remembering that it is base 10 and remembering that you don't actually need to write it in there. You don't even need to say, you could just say log of 10 plus log of x. And then it's understood that it's log base 10. Nice,
Can we
good
get
catch.
Josh for it?
It wouldn't be simplified if you put like a 10 over there, that wouldn't be giving you, I couldn't give you full credit because it's not fully simplified. It'd be like saying an answer is 1x. It's just strange. We know that 1x is x. Any question about B? Can you please show me what log of 10 is? What is log of 10? It's 10 to the what equals 10. That's why the answer is 1. So it would be appropriate to even simplify that further to just be 1 plus log of x.
And so that's it.
That would be the full simplified.
That's what we can't do in this one.
You can, but I always expect you to simplify as much as possible. So we're able to split it up into two different logarithms and then simplify that first one. Upton, where would you see? Oh, I like it. Okay. Is it log on base 33 of what? Well, let's go back a step and think. We're using a product rule here. So how about, what's one way to say 33 as a product? What's times what? I know you know this 11 times 3. So now that we have this, we can use what we're doing to do that. Is what to do next. Yeah. Sure. If you have a log base anything, whatever the numbers are, you can do log versus just like hey, it wasn't log base 435, it was log base 407.5. Log base 47, log base 45. So now that it's a product, this can be reflected from the one and only Upton. So we can make this log of. Yep. Exactly. And it's just that straightforward. Are we good?
So there's no base.
Oh, is there a base?
But you still.
Common is in all
Whatever you do.
I think this is poorly written. It should probably just be log of 33. That'd be clearer, wouldn't it? I think that might. But yeah, that's definitely a common log. How do I know? It's empty there. It's always time, unless you see a base.
So why can't it just be log base 33?
I'm not sure I see any justification for changing this into, like, if we have log of 100, is that the same thing as log base 100? There's probably a relationship there, but that's too complicated for us to figure out. We're trying to keep this very first level of logarithm. We don't want to start changing bases or anything yet. But I can see how the writing would be a little bit strange there. Okay, are we good with those three? Any questions? Okay, remember that b to the m over b to the n is equal to b to the m minus n. So just in the way that we have this product rule, we also have a quotient rule where it says that this, you can probably guess this is equal to log base b of m minus log base b of n, and that's anytime you have a quotient. Summary of this is the logarithm of a quotient is the difference. If you ever have it, I'll call on two people in about 10 seconds. The Siri, can you help me with A, please? What? Oh, log base 7. Okay, thank you. Log base 7 of 19, you said? Do we agree? Thank you. Yeah, it's hard to get these words in your mouth. It's a little different. Oh, and Tyler, help us with B, please. Are we good? So far, so good. Show me what you see. Show me what you see. One step deeper. Show me what you see. Show me what you see. One person got it. I want to go one step further. Check with the neighbor. What do I want? Say numbers. Yeah, should I just erase the twos? Would that be okay? Just make it 8 minus 8. It's X. Well, I don't want to just do stuff. It's not okay to just ignore those twos because that changes the base completely. But I could rewrite log base 2 of 8 because that's just 3. The question is 2 to the what equals 8. We could simplify that to 3. Oh, should we have done that with just series? Did I forget something? It's not very easily simplified at all, but we do know that if you were to somehow type in log base 7 of 19 into a calculator, it would be in between. Show me what your number is. Log base 7 of 19 would be between. You have two hands on two numbers in between. Log base 7 of 19 is between 1 and 2. That's 7 and 49. Okay, we know log base 7 is 1, log base 7 of 49 is 2. So that's somewhere in between. It's somewhere in between. Okay. Lastly, B to the mn here. Now this one's a little bit tricky. Let's say we have a log base m of m squared. I hope that makes sense that it's equal to log base m of m times m. And then using the product rule, we can make that log base b of m plus log base b of m. Are you following me? Two people, right? And then this plus this is equal to There's two of them, 2 log base b of m.
You treat the whole thing as like an X value.
Nice.
Feels like very bad. Exactly, yeah, there's something plus itself, that's by definition 2 times that thing. You can imagine this is an end shooting. It'd be maybe. Log it. Yeah. Think the word n to the 10th power. 10 components.
So that leads us to
So that.
there you go, you found it. Log base b of m. The power of the argument of the logarithm can be rewritten as a coefficient of the logarithm. No s. Powerful tool. For this one is we've got a little exponent, move it down. 4 times log base 5 of 7. Can I do anything with b? Yeah, square root of x is the same thing as saying,
Also, the end of
oh,
that.
let's leave it there. Yeah. For b, I can rewrite that square root of x as x to the 1/2. And now since that's an exponent, I can just bring it down. 1/2 log base 2 of x. That 5, what's going to happen with it? Boom, comes down. 5 times log of 4x. Now notice I was being very specific with my parentheses there. I'm not done. What can I still do? Thank you. We have the product rule here. 5 times log of 4 plus log of x. That would be fully expanded. That's what we're doing here. Expanding the expression. You can either put in parentheses, or you can take that 5 and distribute. But don't just leave it like this without anything. So this, or neither one is better than the other. Log of 4 plus log of x. I think that's what we're asking. Either one's okay. Good question. Okay, so in summary, log base b of mn is equal to, I'll let you finish these. why people have. Does this seem like a pretty logical first step? But Dan has asked the last question, would it become this? If you're doing it right, yeah. Nicely done, thank you. So you can do for B. B is a little bit tricky. Let's see if we get through it. Oh yeah. Then. All right. Are you done with B? I don't want to hear it yet. Has anyone else finished B? Let's give one this chance to catch up. Neighbor, I do want to call on someone, at least to give us a first step. You let destiny choose the way. Before I uncover this, I don't know who's on here. I'm gonna give either Upton, Gideon, Jasiri, or Tyler, but all people who I've called today, a chance to answer this first. And whatever you like to. You're okay? None of you want to? Ready to give it to someone else? Jasiri, you ready to pass this to someone else? Y'all are very kind. One of the things I like about this class. Ethan, you are the beneficiary of the kindness of your peers. Minus, say it again, minus, nice. Are we good with this? Or should we log? Oh, log of this? Is that what you meant to say, Ethan? Oh, you had it in parentheses? Oh, be careful. Right, this is what I'm looking for. That's gotta be the next step. Does that make sense?
Also log base.
Oh, log base. You gotta keep the base. Thank you. Let me write this like a human. Log base 6 of the cube root of x minus log base 6 of 36y to the fourth. This is what I need that first step to be. So far, so good? Here you have at least 50% credit. This or a quiz or a test. You're headed in the right direction. Ethan, do you want to continue? What's that? You haven't finished it? Who would like to continue? Oh, did you say you would? All I heard was I would. Oh, you're not sure? Okay. Oh, yes, Raquel. The cube root.
Log base b of x. and then one.
Does that seem like a reasonable thing to do? Rewrite that cube root?
Wait,
I think I'm focused on that 1/3. I think that is really good.
That's what I did. I skipped right to the 1/3.
Can you write it? Are we okay? So this is really nice. Are we good with this? There's a little issue. It's really good, but it'd be right if it's like this. But that 4 only belongs to the y. So go ahead and discuss with your neighbor, but thank you for helping us with it. At least that first one, take us to the next step. Just want to make sure y'all can.
So parentheses of log.
What's that? Let's see what you're doing.
I look at it and I'll be like, why is it like? In my hand.
Okay, folks, it's tricky. Anyone want to do it the next step? Yeah, Ben?
I think. Go to 1/3 log base 6x minus 862 plus 4 log base 6y.
Let's get a step back before
Yeah,
that.
I concur with Ben. Yeah.
I like it.
So right now I go 1/3 log base 6x minus parentheses log base 6 plus 4 log base 6y.
I can take a step. I can take it just another step back. Does that make sense as the next step? It's a product, and Raquel, this is how we get that for working for us. And I think Ben, I really like how you did that for immediately. I think that we may already be at that place where we could just put that exponent down quickly.
Yeah.
But you said something else. Do you all see what he said? Do you see what he was talking about?
I like that too.
Do you see the two?
How we did it earlier with the,
Right here, log base 6 of 36. 6 to the what equals 36? 2. 6 squared. We know what you mean. Yeah, so we have 1/3 log base 6x minus 2 plus 4 log y. But this just feels a little bit awkward. Yeah, that's what I would expect at the end. This isn't like a polynomial where like the highest degree has to come first. So no more degrees here. If you want to put that constant at the end, you can. But this is a perfectly fine answer. Any questions? Okay, the time is now 1 o'clock. We're going to resume at 1:04. That's time to ask questions for clarifying if you need to.
But you get rid of the base, it's for the, for
Oh,
four log y.
It should still be basics. I'm being super lazy.
Okay.
Good catch. Thank you. Yes, I'm going to check homework now.
We're not done. Okay.
Yeah.
Mine's gonna be an ace. No matter how hard I work, how. No matter how hard I get use an answer. I will always get an A line.
Fine, I'll go with it, about it, like, I know.
You just kind of like say that. You just kind of like, I just say what. That class is so good. I love that. That's it. I've never like. Boom. So. Come in. One thing we can. So chill. And like it's still like a good class. And it's only feels like. Next.
The only thing is, she only sees in the lunch, or like, we're the only time that I do
That. Yeah. Then.
Okay, let's continue. And excuse me for being sloppy with the bases. We don't normally use bases other than 10 once you get past this level. So I'm just being, it's kind of, I'm a creature of habit. So it's mindlessness or carelessness on my part. So thank you for calling me out when I forget that base. And finishing it up, we've just expanded. Now we're going to do the opposite. We're going to condense into a single logarithm. Do you see how that's going to work here? Take that 2 and take 32 and multiply them. How do you know we're multiplying them? Yeah, that's just a product rule, just going backwards. So we have log base 4 of 64. Log base 4 of 64. That, I feel like that's something. Is it? And 4 times 16, you write is 64. 4 times 3 is 64? 4 to the third. Okay, getting it right there. You're on the right track. Well, that's good feedback. Let's see. The first thing we're gonna do here is, oh, should I distribute this log? No, never distribute log, please. But with this one, I'm going to rewrite that as. Are we good with that? Am I done?
If that's the left term is log, lower actually.
Oh, is it, could I break that up into 4x over 3? It looks like it, but it's not. Yeah, which of the rules can I use here? Any of them? Product, quotient rule? It's a quotient rule, like backwards, isn't it? So we know that log base b of m minus log base b of n is equal to log base b of m over n. That's the quotient rule. So we're just doing that backwards. Log of 4x minus 3 over x cubed. Nice. Did you already get C? I'll give you a minute. C's oh, tricky.
Oh, we're basically like condensing.
Yes, that's exactly what the opposite of what we just did. Hint. Factor out. What do you think we have to factor out? Factor out. Minus. Just want to think of that negative, it's gonna become plus 1/2. Log base B implied. But maybe at this step, you already want to take those, that 2 and that 1/2. And yeah, put them back. Make them. Should we just do that while we're back at the negative 1? Is that cool? It depends. Yeah. Yes, 1 and 1/2 is root. Minus, so inside of parentheses, let's do that first. That's gonna become log base B of 36 times square root of y. Does that make sense? That's the product rule going backwards. Oh, what should I do with that 4? That's I'm done. No, it said write it as a single logarithm. So now I'm going to take this and make it log base B of. I need a fraction here because it's a difference. So on the top is x to the 4th. On the bottom is 36 square root of y. Just the quotient rule with the product rule. And the product rule and the exponent rule. All of it. Last one, I believe. Yeah. I'll leave that for you. What's that? Oh, I don't mind zooming in at all. Can I write anything for you? This is a B. I don't need this dot for multiplication. Okay. We'll see. You may be saying to yourself, what the heck? Oh, what? The helicopter? 6 changes to 3 times 2. Now this is just an exercise in how well do you know the properties. I can rewrite this now as log base B of 3 plus, what's that? If it's a 10, you don't have to write it. And if you're being lazy, then you don't write it, and then I take points off, or you tell me that I'm being lazy. Right now, I just be careful. That's all I'm saying. Yes, so it tells us here that log base B of 3 is C, and log base B of 2 is A. The A plus C or C plus A. Any questions? Something special about 81. It is 3 to the 4th. So 4 could come down. Log base B of 3. Log base B of 3 is C. Be careful. The exponent had to come down first. Log base B of, oh my gosh. This is square root of 3 over square root of 16. Log base B of square root of 3 minus log base B. What is the square root of 16? I do believe it's 4. Square root of 3 is the same thing as saying 3 to the 1/2. 4 is the same thing as saying 2 squared. take them as exponents, 1/2 log base b of 3 minus 2 times log base b of 2. And now we have it 1/2 c minus 2 times a. The three things I need to take you to take with today's lesson. Could you please discuss with neighbor what are the three things you need from this lesson? Yep. These are the three things you need. You must have them. Okay, folks. You have a little bit of time to work on your assignment. I will publish it now. I haven't published it yet.